Good morning, students. In previous class, we discussed about what are the different types of finite automata, what do you mean by finite automata, how we are going to represent the finite automata in states, right. In this session, I am going to discuss about what are the different types of finite automata. Here, there are two types of finite automatas are there. First one is the DFA, second one is the NDFA or NFA. Here, uh, DFA means deterministic finite automata, NDFA or NFA means non-deterministic finite automata. Finite automata is classified into two types. One is the DFA, second one is the NDFA. DFA means deterministic finite automata, NDFA means non-deterministic finite automata. Your complete automata theory subject is depends upon these two things, DFA and NDFA. Now, in this session, we are going to discuss about DFA, deterministic finite automata. Here in deterministic finite automata, here we are having only one input, one output. Here whenever we are going to apply any single input on any state, we are going to get only one output state. That's it. Single input, single output. This is the main concept of DFA. In DFA, for each input symbol, one can determine the state which is the machine will move. Hence, it is called the deterministic finite automata. Here, in deterministic finite automata, we have to apply, yes, for example, see here, in this case, Q1 is one state, right? Here, initial state is there, so it is indicated by arrow, right? Here, whenever I am going to apply 0 input on Q1, I am going to get only one state, that is Q2, right? Here, single state, single input, we are going to get single output. This is the DFA, right? In some cases, in some automatas, here we can apply single input on state, we are going to get multiple number of states. For example, same here Q0, we are going to get some another state, that is Q1. For a single input 0, we are going to get two states. So, here this is not the DFA. DFA means single input, DFA means single input Q0, right? Whenever we are applying 0 on Q0, we are going to get only one state, that is Q1. That's it. Single input, whenever we are going to apply single input on any state, we are going to get only single output, that is the DFA. Here in DFA, we are having finite number of steps. While we are going to constructing any DFA from the finite automata, that particular finite automata must consist of finite number of steps, then only we can call that machine is a deterministic finite machine, right? If any finite state machine is having finite number of states, then only that particular machine is known as the deterministic finite state machine or deterministic finite automata, DFA. In DFA, we are having finite number of states. Here, DFA, finite automata, is classified into two types. First one is the DFA, second one is the NDFA. In DFA, we are having single input and we are going to get the single output, right? And in DFA, we are having finite number of steps. If any finite automata is consisting of finite number of steps, then that particular finite automata is known as the deterministic finite automata. Already in yesterday's class, I discussed every finite automata is consisting of five tuples, right? Here, in the same way, DFA is also consisting of 5 tuples: Q, sigma, delta, Q0 and F. Every finite automata is having these 5 tuples: Q, sigma, delta, Q0 and F. What do you mean by Q? Q is the number of states. Q is the number of states, right? Here, sigma is the number of alphabets. Already we discussed all those things in previous session, right? Sigma is the finite set of symbols called input alphabets or alphabet. Here, transition function. Already in yesterday's class, I discussed about transition function. Transition function is depends upon that particular finite automata. Transition function is depends upon the finite automata. Here in this DFA, transition function is Q cross sigma into Q. Q cross sigma into Q. here it should be follow this property, it should be follow this property, right? Here for every DFA or every finite automata we are having different types of transition functions. Here in deterministic finite automata we are having delta is q cross sigma into q, right? Next, Q naught. Already I explained what is Q naught. Q naught is the initial state. Q naught is the initial state. Here in DFA we are having only single initial state, and that particular Q naught is present in this Q, right? Q is the number of state. And one more thing, Q is the finite set of states. Q is the finite set of state. Why? Because in DFA we are having finite number of states. In DFA we are having finite number of states. That's the reason Q is having finite number of states, right? Next is F. F is the set of final state. F is the set of final state. Here in F is the final state. Here in DFA we can have multiple number of final states. We can have multiple number of final states. Multiple number of final states. Multiple number of final states are present in DFA, right? Up to here clear? DFA is consisting of 5 tuples, Q, sigma, delta, Q naught and F. Q is the number of states present in the finite automata. Sigma is the number of input symbol. Delta is the transition function which maps Q cross sigma into Q. Next is the Q naught is the initial state. F is the set of final state. In DFA we can have multiple number of final state. In DFA we can have multiple number of final state. Here we can represent this DFA by using the transition diagrams or state diagrams, right? Next is the graphical representation of DFA. Already I explained. Here DFA can be represented by using graphs, right? DFA can be represented by using graphs. These graphs are known as state diagrams or transition diagrams. These graphs are known as the state diagrams or transition diagrams. One more important thing is DFS, all DFS are directed graph. All DFS are directed graph. Digraphs means directed graph. Directed graphs. Here already you know that what is the directed graph. Here generally graph, what do you mean by graph? Graph is a set of vertices and edges, right? Here if any graph is having the direction, then that particular graph is the directed graph. Here how we are going to represent this direction? In this format or in this format, right? This is the edge. This edge is having, if any edge is having any, so for example A, B, C is the graph is there. Now see here, this is the directed graph. This graph is consisting of 3 vertices A comma B comma C, and edges are from B to A edge is there, A to C is there, C to B is there. Direction is indicated. That's the reason this graph is known as the directed graph. While you are going to represent the DFA, deterministic finite automata, that particular DFA must be directed graph. Why this DFA is a directed graph? Why? Because whenever we are going to apply a single input on any state, we are going to get only single output. That's the reason DFA is the directed graph. If undirected graph is there, means for example here, see here, A, B, C. See here in this example we are saying B to A. Here we can write A to B and B to A. Why? Because this edge is counting twice. This edge is counting twice. Here this edge is counting only one time. Right? Now the vertices represent this state. Here this is the vertex. Now this vertex is represent the state of the DFA. This vertices are represent the states of the DFA. The arcs labels with an input alphabet show the transition. See here, I am giving the directions now. Here I am going to draw one more graph here. Q0, Q1, Q2. So Q naught is the initial state. That's the reason I am going to put the arrow mark here from Q naught 0 and Q naught 1. Here Q1 on 0 is the self loop. Now Q2 on 1. See here, right? All the arcs labeled with the input alphabet. See here, all the arcs. This is the arc now. This is going to labeled with 0, 1, here 1, here 0. All these arcs are, all these edges are labeled with the input alphabets, right? Now, the initial state is denoted by the empty single incoming arc. See, initial state is indicated by this arrow. Initial state is indicated by this arrow. This is the arrow here, initial state. Arrow mark indicates, see here, Q1, Q2 is there. There is no arrow mark is there. Initial state is indicated by this arrow mark. In the last session only, we discussed about the initial state. Next, final state is indicated by double circle. See here, in this graph, is there any final state is there? No. For example, here I am going to representing this Q1 is the final state. So, whenever I am going to putting this Q1 is the final state, so I have to mark this Q1 as the double circle. See here, Q1 is the single circle, Q2 is also single circle, Q2 is the double circle is there. That's the reason Q1 is the final state, right? This is the graphical representation of DFA. In graphical representation of DFA means, what is the first point? Here first point is every graph is a directed graph. While you are going to representing the DFA, every graph must be a directed graph. Next point is, here all the vertices are represented by the states of the DFA. All the vertices are represented by the states of the DFA. Now, what is the third point? The edges labeled with the input alphabet shows the transitions. Here every edge which is present in the DFA should be labeled with the input alphabet. Fourth one is the initial state. How we are going to find the initial state? Any state which is having one arrow mark, that particular state is known as the initial state. Then what is the final state? Any state which is having double circle, that is the final state. This is the graphical representation of DFA. You must remember all those points, all these points. These are very, very important points while you are going to constructing any DFA or converting any DFA to NDFA. Here we are not saying this is the graph. We are saying that this is the transition diagram of a DFA. Transition diagram of a DFA. Now see here, I'll explain with an example. Here, see here in this example Q, how many states are there? A comma B comma C, right? A comma B comma C are the states. Next, what are the here sigma? What are the input states? Q comma 0 comma 1 is the input symbols. 0 comma 1 are the input symbols. Next, which one is the initial? Q naught indicates the initial state, right? Initial state, right? F is the final state. Here F is the final state, right? Here see here, while we are going to represent the DFA, we are having 5 tuples now, right? Q, sigma, delta, Q naught and F. These are the 5 tuples now. Here Q indicates the number of states. See here, Q indicates the number of states. Here this DFA is consisting of how many number of states? A comma B comma C. 3 number of states are present in this DFA, right? Next is the sigma. What is sigma? Sigma is the input alphabets. Here, how many input alphabets here present? 0 comma 1. 2 input symbols are present in this DFA. What is the delta? Delta is the transition function. In next slides, I am going to explain what is delta. Next is Q naught. Q naught is the initial state. Here Q naught. Which one is the initial state? A is the initial state, right? A is the initial state. F is there. What do you mean by F? F is the final state, set of final states. Here in this example, C is the final state. So C is there. C is the final state for this DFA. Now transition diagram. Here while you are going, here these are all the input symbols. Here by using these 5 tuples, you are going to write these things. What is Q, sigma, A and C. Now see the transition function. See here, this is the transition function delta. See here. This is C, right? Here, number of states in the previous slide, here Q is A comma B comma C. See here, A comma B comma C. Here, this is the transition table. This is transition table. This is transition graph. Transition graph. This is transition table, this is transition graph. Here in problem you are going to get either transition table or transition graph. You see here, in transition function is given below. By seeing this transition table, I am going to draw this transition graph. Here how many number of states are there? Here A, B, C. 3 states are there, right? See here. Which one is the initial state? A is the initial state. See here, I am indicating this arrow mark A, Q0, right? Next, which one is the final state? C is the final state. C, double circle, C is the final state. Now, here number of input states 0, 1. See here 0 and 1. These two are the input state. These two are the input states. Q A on 0. See here, A on 0. You are, whenever we are applying A on 0 input, what you are getting? This A. See here, A on 0. You are getting same A, right? We are getting same A. Now here A on 1, what we are getting? B. See here, A on 1, we are getting B, right? Now B on 0, see here, B on 0, what is B on 0? B on 0 is C. Sorry, B on 0 is C. B on 1, B on 1 A, B on 1 A. C on 0, C on 0 B, C on 0 B. C on 1 self loop. C on 1 we are getting the same state. This is known as the self loop. This is known as the self loop. If we are going to get the transition function, we can draw the transition diagram, right? See here, now I'll give second example. Draw the transition graph for the given transition table. Here, see here, how many number of states are there? A, B, C, D. Here, this transition graph is consisting of 4 states A, B, C, D. A, B, C, D. 4 states are there. Now, I am going to draw the transition graph for the given transition table. By seeing this table, are you going to recognize which one is the initial state? See here arrow mark is indicating. Arrow mark is there for A. That's the reason A is the initial state. A is the initial state. I am indicating A as the initial state. Right? A is the initial state. Now, here by seeing this transition graph, are you going to recognize which one is the final state? See here, A, B, C, D. D is having something special, right? D is having something special. The star is there, right? Here, final state is going to recognize directly by seeing the transition table or transition graph. That particular state is having some different mark. In this example, here star is given. That's the reason here we are giving this star. We are indicating this. We are taking this D as the final state. While we are going to draw the transition graph, initial state is indicated by this arrow mark. Final state is indicated by double circle, right? Double circle. D is the final state. So, we are going to draw this double circle up to here. Up to here clear? Right. A on 0. Whenever we are applying 0 input on A, whenever we are applying 0 input on A, what we are getting? C, right? So, A on 0 is C. A on 0 is C, right? A on 1, A on 1 we are getting B. Here, where is the B state? See here, A on 1 is B. A on 1 is B, right? A transitions are completed. Now go for the B. B on 0, C. B on 0, C. B on 1, B, that is the self loop. B on 1, B. It means that the self loop. Whenever we are applying any input on any state, if we are going to get the same state, that particular transition is known as the self loop transition, right? Here here we are applying one input on state B, we are getting the same state, that is 1. B on 1, B, right? C on 0, C on 0, C on 0, self loop, C on 0. C on 1, D, C on 1, D, right? Completed, C transitions are completed. Now, D on 0, D on 0, D, right? D on 1, same transition, D on 1, we are getting the same thing, D. That's the reason I am going to separate by this comma and we are going to put this 1. 0, comma 1, we are getting D, right? This is the transition graph. How we are going to construct the transition graph? By using the transition table, right? Here in this session I am going to conclude I am going to conclude with this transition graph. In next session I am going to explain how we are going to accept this string by using the finite automata. Thank you.